Hi everyone, what we're doing here is we're creating a plot of the average and its 95% confidence intervals. We're using data from the Rio Olympics. These are the weights and heights of sailors. These are the weights and heights of the rugby players who competed. And first thing I'm going to do is I'm going to calculate some properties of those samples. I'm using the Olympic sailors and rugby players as a sample for sailors and rugby players. It's not my whole population. So first I calculated the average using the average function. Then I calculated the standard deviation of that sample. And because it's a sample, I used the stdv.s function. I count the size of the sample n, just using the count function, and I'm going to use a confidence interval of 5%. So I put 5%. Naturally, it can change. Then, I calculate my confidence interval using the confidence.t function, and again, I'm using the confidence.t function because it's a sample. It's not the whole population. Now, let's do it together. We said that this is our alpha, 5%, and that's the calculated standard deviation. And this is the size, 152. Now, once I've done all the proper calculations, I can just copy them and paste them to the other columns. Let's have a quick look at the results. You can see that the average rugby players is 183 centimeters high, or 1.83 meters, and he weighs more than 90 kilograms. And for almost the same height, a sailor is only 77 kilograms. Rugby players are stronger. And just not to waste time, I've pre-prepared a bar chart here with the data for the weight. You can see the rugby players is 90 kilograms and sailor is 77. But we wanted to have error bars with the standard errors in them. So let's just press the plus here and ask for error bars. Thing very easy. Mind you, this is worthless. What Excel does with his error bars is just trying to confuse us. Now let's just do some formatting so everything we can see it easily. Okay, so these are our error bars, and I told you this is worthless. What Excel does, never mind what it does, this is just junk. Every time you get an error bar, vertical error bar, you will have to do what I'm going to show you now. What I do, I go here and I go to personal adjustment, and I have to put in the values of the error bars because it's normally distributed, or we assume it's normally distributed. I need to put the values for the positive error, and we said we're working on the weight of rugby players and sailors, and because it's normally distributed, it's the same positive and negative error, and now it's okay. You can see that the errors are quite small, but you can see it also here. That's the error, the 95% confidence interval of the mean for the rugby player's weight and for the sailor's weight. It's very small compared with their weights. Of course, we need to be able to see it. So let's close the margin. And that's a nice plot. We're done. Thank you.